Quadratic functions are equations in the form of f of x is equal to ax squared plus bx plus c. But we've seen them mainly so far in the form of f of x is equal to a times x minus h squared plus k. And that's mainly because we've been doing with transformations. As you recall, this is a horizontal transformation, this is a vertical transformation, this is vertical compressing and stretching, and if there was a minus sign out in front of here, that would mean there is a reflection across the x-axis. But from now on, we're mainly going to be dealing with equations in the form of this. And there's not really much to say about this section. It's stuff we have already gone over. It mainly deals with graphs of quadratic functions and the vertex, and most of you probably already know what the vertex is. I'll just point it out. The vertex is the center, is also the center of the parabola, the vertex, and that's at hk. So it talks about this, talks about stretching and compressing, and it's a complete waste of time, to be honest, because we've already spent a whole section talking about that, and it's not any different. So I'm not really going to say much about graphs. The only thing I'm going to talk about and mention is maximum and minimum values, because I'm not sure they went over that. I don't think I did. But it's real simple. A maximum value is when we have a graph that points downwards, and a minimum value is when we have a graph that points upwards. So let's draw two parabolas. So when we have a parabola that's pointing upwards, the vertex is the lowest point on the graph and is the minimum value. So when we have an A, as you recall, when we have a positive number out in the front, that means the graph is pointed upwards. And if we have this minus sign, that means it reflects it across the x-axis, which would mean that we had a maximum value instead of a minimum value, because this vertex would be the highest point on that graph. So maximum and minimum values can just be summarized as, if A is greater than 0, it's a minimum value. And if A is less than 0, it's a maximum. And that maximum or minimum value is just going to be whatever y is at the vertex. So the vertex is either going to be the lowest point of the graph or the highest point of the graph, depending on which way it's pointed. So that's all really for graphs. Everything else you already know. So this section is really a complete waste of time. The only thing I really want to talk about in this section is how to convert our standard form to this form with the vertex. Because sometimes, especially when we are graphing, it's obviously much better to have this form, because we can clearly see the vertex, whether it's being stretched or not, and whether it's being reflected across the x or y axes. So in order to do that, let's take an example. Let's say we have the equation f of x is equal to 2x plus 1. And I want to convert it to the form in which we have f of x is equal to a times x minus h squared plus k. And now in order to do that, there's a very simple formula to use. And I'm going to show where this formula comes from, but let's solve the problem first, and then we'll see where this comes from. So we get this formula. H is equal to minus b over 2a and we have k is equal to 4ac minus b squared over 4a. So all we have to do, and well, it's important to note that this equation is already in the form of ax squared plus bx plus c. So in order to fill in these equations, what we do is go over to our original equation, figure out what our coefficients are for a, b, and c, and then we put them into this equation. and that gives us the h and the k, and then we can find the a from our original equation, which in this case is 2. So all we have to do is solve for these equations. So our a is 2, our b is 1, and our c is 1. So let's just fill in this equation and or just fill in these formulas and figure out what our different values are. So we have h is equal to minus b, which is 1, over 2a, which is 2. So this is going to give us minus 1/4. So we already have our h. Now we want our k. K is equal to 4 times a, which is 2, times our c, which is 1, minus b squared, minus 1 squared, which is our b, over 4 times a, which is 2. So this is going to give us, let me write it over here, so k is equal to 4 times 2 times 1, which is 8, minus 1 squared, which is 1, over 4 times 2, which is 8. So this is going to give us 7 over 8. So let's write all of our values down here again. We looked up here in our original equation, and we saw that our a is 2. So our a is 2. Our h is minus 1/4. And our k is 7 over 8. So now we just put it into our equation. So this is equal to 2 times x minus 4. So that makes it a plus 1/4 squared, and then plus 7/8. So this is equivalent to our original equation, 2x squared plus x plus 1. And if we wanted to prove that, all we have to do is just multiply all this stuff out, and we should get back our original equation. So let's do that real quick. So we have 2x plus 4, 1/4 squared, plus 7 over 8. So let's expand this. We're going to get 2 times x squared plus 2 times x to 1/4, so that's going to give us plus 1/2 x, and then 1/4 times 1/4, so that's going to give us 1/16, plus 7 over 8. We multiply all of that by 2, we get 2x squared plus x plus 2/16, which is 1/8, plus 7 over 8, and this is 2x squared plus, it's a crooked plus x plus 1/8 plus 7/8, so that's just 1. And that's our original equation right there. So we can see that these formulas work. Now another question might be, where do they come from? And I'll show you where they come from. They come from completing the square of our standard form. So we have a x squared plus bx plus c, and I want to get this to look like this: a times x minus h squared plus k. And like I said, what we do is we go about completing the square. So the first thing to do is to divide out this a, because we have x minus h, so we want x by itself. So the first thing I do is I get x squared plus b over a. So what I've done is I've divided out all the terms by a, plus c over a. Now the next thing to do is to complete the square of this. So we get x squared plus b over ax plus b squared over 4a squared. Just my other card. Oh, there we go. Plus c over a, and then what we add, we must also subtract. So minus b squared over 4a squared. And if you want to know where this 4a squared comes from, it comes from completing the square, like I said. And this might be a little bit tricky because of the 4, but remember, if we want to complete the square, we have to take b over 2 squared. And in this case, b is b, so the b term. And this comes from our, and when this refers to b, it's talking about the b right here. And in this case, our b is b over a. So this is b over a over 2a. So it would be the half of b, 1/2 b over a, which is b over 2a. And when you square this, you get b squared over 4a squared. So that's where that comes from. And I'm subtracting it here. So when I simplify this, I'm going to get, let me pick back my original color. So I'm going to factor this. So I get x plus 1, oh, I'm sorry. So b over 2a. So this gets rid of that. But we're still left with this, plus c. And this is squared, by the way. Plus c over a minus b squared over 4a squared. Now the next thing I can do is I can put these over a common denominator. So what I can do is I can multiply. So what I want to do is I want to get this c part of the same fraction over here. I want to merge these into one fraction. So what I can do is I can multiply the top and bottom by 4a. So if I multiply the top and bottom by 4a, it still makes this fraction equal, but what I'll be able to do is put these fractions together. So if I multiply the top and bottom by 4a, scroll down, x plus b over 2a squared. So I still have this, so I multiplied the top and bottom of this by 4a, so I get 4ac over 4a squared. And anytime I want, I can just divide out 4a, and then I'm back with my original c over a. But I have this b squared over 4a squared over here, and then what I can do is say that these are both under the same, these are both over the same fraction. They have the same denominator, so I can just put them together. And then I get x plus b over 2a squared. And then I put these together, so I get plus 4ac minus b squared over 4a squared. And if you notice, this is in the form of a x minus h squared plus k, where we can see that now we know why h is equal to minus b over 2a. So we can see that we take out the minus, and now it's in the form of x minus h. So h is minus b, and we can see that k is equal to 4ac minus b squared over 4a squared. So that's where this comes from.